let's talk difference quotient. Now, the difference quotient is used to find the rate of change between 2 points, and really the more important thing, it's the foundation of the derivative in calculus. Now, the formula for the difference quotients is f of x of plus h minus f of x all over h. All right, so this represents the slope. Remember, this x plus h, we're going to plug that in for x of whatever function we have. So let's go ahead and play with this. So we're going to find and simplify the difference quotient for the function below. So let's remember the difference quotient is f x plus h minus f of x all over h. And big thing to remember, h can't be 0, because if h is 0, the whole thing doesn't work. We cannot divide by 0. So just something to keep in mind for our problems here. All right, so let's start with plugging in x plus h for our function. So we're going to have x plus h squared, right? Because instead of x, we plug in x plus h. Then we're going to subtract the function, which is x squared, and that's all over h. Well, we now need to simplify the numerator. So let's remember that x plus h squared is x plus h times x plus h. So whether you use the box method, double distribution, however you want to call it, FOIL, you're going to get the same thing. You get x squared plus 2xh plus h squared, and then we subtract x squared all over h. So we have expanded our binomial. Now we see, well, x squared minus x squared, those like terms actually cancel out. And I'm left with 2xh plus h squared all over h. Well, beauty, that h's are in all three terms. So I can simplify everything by a factor of h. So if I cross out factors of h, my final answer is 2x plus h. And remember, h can never equal 0. So this find and simplify, we have 2x plus h is our final answer. All right, let's do another one. Now our function is f of x equals 1 over x, and we are going to find and simplify the difference quotient. So again, let's remember the difference quotient is f of x plus h minus f of x all over h. I highly recommend you write that down before you start every problem, because writing it down, talk about it out loud, you're going to remember it more. So we start by plugging in x plus h for x in our function. So we have 1 over x plus h minus the function, which is just 1 over x, and that goes over h. Once again, h cannot equal 0. Do not forget about that. Now we need to divide this by h, and all of that is great, but right now we have ourselves a complex fraction. So I'm going to start by getting my numerator to be a single fraction. So in my numerator, I need a common denominator, and that common denominator is x times x plus h. So to do that in my first fraction, I'm going to multiply by x. So I get x. Now I'm going to subtract. In my second fraction, I have to multiply by x plus h. So that gives me x plus h all over x times x plus h. We're still just working in the numerator. Now, in the numerator, I have to distribute the x. So that gives me x minus h all over x times x plus h. Okay, so I distributed the negative. That gave me the negative x, the negative h, and then I still have the x that comes first. So hopefully we see x minus x goes away, and I am left with, this is my numerator, negative h all over x times x plus h. All of this is dividing by h, okay, because all of this here was my numerator. So that means I have negative h all over x times x plus h divided by h. Well, how do we divide fractions? We take the first fraction and we multiply by the reciprocal of the second. When we do that, our h's cancel out and we're left with negative 1 over x times x plus h. Remember, h cannot equal 0. That's a long problem, because our first step is that we have to work with our numerator first. We've got to get that numerator to be one fraction so that we can then divide our fractions. All right, let's do one more. Find and simplify the difference quotient for the function below. Now we're dealing with the square root. So once again, we have x of x plus h minus f of x all over h. All right, so let's start by plugging in the x plus h. So I have the square root of x plus h minus our function, which is just the square root of x. All of that is over h. Once again, h cannot be 0 because we cannot divide by 0. And you might say, I don't know what to do with this. Well, we're going to need to rationalize the numerator. So to rationalize the numerator, we are going to multiply by the conjugate, which is the square root of x plus h plus the square root of x. Now, if you recall, the sole purpose of multiplying by the conjugate is that the middle terms cancel out. So the radical x plus h times radical x plus h just gives me x plus h. And the square root of x times the square root of x just gives me x. And I have a minus sign, right? Minus times plus gives me a minus. In the denominator, I have h times x, the square root of x plus h times the square root of x. In my numerator, the x's cancel out. X minus x is 0. And you may also notice that because I then have h over h times the square root of x plus h plus the square root of x, my h's are going to cancel out. And so my final answer is 1 over the square root of x plus h plus the square root of x. And we all know that h cannot be 0 because in the difference quotient, we cannot divide by 0. Well, we can never divide by 0, but also we have an h in the denominator, so it can't be 0. So we have to know how to rationalize, in this case, numerators. We have to know how to square binomials. All of those kind of basic algebra skills that you have to load to be able to do the more advanced algebra and get into calculus. So make sure you're paying attention, taking each step one at a time. And if you need help on any of those, go back and watch a previous video.